Hey guys, welcome to Math Failure channel. In this video, we are going to solve 10 difficult questions on the indices or exponents. So as written here, we have SAT prep math, okay? So difficult indices, exponents. We have 10 questions here and we are going to solve them together. Okay, let's begin. Question number 1. If 2 raised to the power of x plus 1 plus 2 raised to the power of x is equal to 96, what is the value of x? Well, let's begin. So since our topic is on the indices or exponents, we can go ahead and then talk about maybe a few properties before I move. In each question, I will show you the property that we should use. Okay, so for example, in this question here, you need to know that a raised to the power of maybe x plus maybe c or something like that. This is the same as a, okay, let me say is equal to a raised to the power of x, then multiply by a raised to the power of c. Because in indices, when we multiply two numbers together whose bases are the same, we add the powers. Okay, so these two are equal. Okay, the base is a, the base is a, so if you multiply them, it's just as adding the powers together, which will be x plus c. So these are the same. Let's go ahead and solve this question. Okay, I'm gonna move. All right, so we have 2 raised to the power of x plus 1. So we are going to break this down to 2 raised to the power of x multiplied by 2 raised to the power of 1. As I explained in this example here, okay, this is the same as this. Okay, let's continue. Plus, we have 2 to the power of x is equal to 96. And from here, well, 2 raised to the power of 1 is just 2, right? So let's write that. Let's say we have 2 multiplied by 2 to the power of x, okay, multiplied by 2 plus 2 raised to the power of x is equal to 96. Then from here, let's factor out 2 raised to the power of x. Let's factor this out. Okay, we have 2 raised to the power of x here, 2 raised to the power of x here, so we take them out of a bracket. That will be here 2 raised to the power of x. We open the bracket. If you divide 2 raised to the power of x here, this and this will cancel, so only 2 will be remaining. We have 2 here, plus if we take 2 raised to the power of x from here, they will cancel each other, so 1 divided by 1 is just 1, and this is equal to 96. Sorry, let me write that better. Okay, 96. Let's continue. 2 raised to the power of x, well, 2 plus 1 is 3, so multiply by 3 is equal to 96. Then from there, we want to have 2 raised to the power of x on its own, so we divide both sides by 3 so that we can get 2 raised to the power of x on its own. Well, 3 goes into itself 1 times, 3 goes into 9 is 3 times, 3 goes into 6 is 2 times. You can also use a calculator for this, okay, because in SAT you are allowed to use calculator, so you can go ahead and use your calculator if you are not comfortable with division. Okay, so this is the same as 2 raised to the power of x is equal to 32. Now, because we are dealing with indices or exponents, we have 2, and then the exponent is that's x. Okay, it's raised to the power of x, but we have 32 here, so we have to change 32. Okay, we have to convert it into indices because we are dealing with indices or exponents, so we have to convert 32 into indices. Okay, so what is 32? 32 is the same as 2 raised to the power of 5. Okay, and if you don't know this, you can just use a calculator, because we are dealing you are dealing with base 2 here, so there's a high probability that this is also going to be in base 2. So you can multiply 2 by itself again and again until you get 32, if you don't know, of course. But for the sake of this video, I know that 32 is the same as 2 raised to the power of 5, so I'm just going to say 2 raised to the power of 5. So this is the same as 32, okay? Then from there, in indices, as you know, if the bases are the same, we just equate the powers. Then from here, x is just equal to 5. Okay? So in this question, our value of x is 5. That is option B. You can go ahead also and then verify. Let's verify and see. 2 raised to the power of, instead of x, let's put 5 plus 1 plus 2 raised to the power of 5. If you point this into your calculator, you'll get 96, okay? If you replace this x here, this x is here, with 5, the answer you will get is 96. And by the way, another method also to get this question correct, because this indices are easy. I mean, like, if you have multiple choice questions, okay, with indices, without doing any of these calculations, you can just go ahead and then do trial error, okay? You start from A, you say, okay, let x be equal to 4. You replace 4 here, you replace 4 here, you punch it in your calculator. If this is not equal to 96, then you eliminate this. It's not the answer. You move to B. If you plug 5 here and then the result of this is 96, then it is the answer. Just circle it and then pass. You don't need to do all these calculations. But for the sake of this video, everything is in ABC, you know, multiple choice questions. But on the SAT, you have both multiple choice questions and you also have non-multiple choice questions, okay, where you have to generate the answer by yourself. So you need to know the rules and then how to find the solutions, of course. Yeah. That being said, let's continue to question number 2. Question number 2. If 9 raised to the power of x minus 1 is equal to 27 raised to the power of 2x minus 3, what is the value of x? As I said, since we have multiple choice questions, you can just go ahead and do trial and error. Start from A to D. You just plug the values here and see. If you plug the value of 0 here, you punch this, you have the result of this around here. Then also plug 0 into x here and then punch the value. If these two sides are equal, if the left hand side, okay, is equal to the right hand side, then that is the answer. Just circle it and move, okay? That's, of course, if you have multiple choice questions. Otherwise, you have to solve, okay? So, but for the sake of this video, I'm just going to use the solution method. I'm going to solve the questions. Let's go ahead and solve this. Again, we are dealing with indices. So, we have to make sure that we convert the numbers into their indices, okay? Into like similar forms. Like, for example, here we have 9, okay? It has an exponent. We have 27 here. It also has an exponent. But well, the bases are not the same. So we have to make the bases the same, because in order to be able to equate the powers, the bases should be the same, okay? I think you all know that. For example, when you have A raised to the power of maybe B equal to A raised to the power of C, because A and A are the same, the bases are the same, we can go ahead and say this. But exponents are equal. We can say B is equal to C. But that is only possible when the bases are the same. Well, in this question, we have 9, 27. They are not equal. So we have to make them equal. How do we do that? Well, we convert them into some indices of bases. I don't know. It can be any base. So let's see here. Well, when you look at 9, 9 is the same as 3 raised to the power of 2, right? And because we have this exponents here, let's just go ahead and write that. Again, open a bracket, because you have two terms. Don't make that mistake of writing 3 raised to the power of 2, 2 multiplied by x, 2x, then minus 1. You forget to multiply the 2 by the minus 1. You'll get the question wrong. And there is a high probability that when you do this type of operation, you are going to find something here in these options that matches, and then you just circle it, you get the question wrong. So make sure that if you have terms here, you make sure that you open a bracket, okay? That shows that the 2 is distributing, yeah, distributing the 2 over the bracket. Okay, let's continue. We have this is equal to, and this side of 27 can also be expressed in form of base 3. Well, 27 is what? 27 is 3 raised to the power of 3 is 27. Again, we have 2 terms there, so we have to open a bracket. This. Well, remember what I just explained here. If the bases are the same, the exponents are equal. The base is 3, the base is 3. Therefore, these powers are equal. Let's go ahead and equate them. And we can say 2 into x minus 1 is equal to 3 into 2x minus 3. From here, let's continue around here. Let's distribute 2. That is 2 multiplied by x, 2 multiplied by minus 1. Well, 2 times x is just 2x. 2 times minus 1 is minus 2. And this is equal to, again here, we are distributing the 3 inside the bracket. Okay? 3 times 2x is 6x. 3 times negative 3 is negative 9. Okay? Minus 9 here. And now the thing is easy. Just move 2x to the right hand side and then negative 9 to the left hand side. And this will be negative 9 to the left hand side. The sign will change to positive 9. Okay, that is 9. There's already minus 2. Okay, this is equal to, we have 6x at the right hand side. If you move this, the sign changes to negative 2x. I think you all know about that, negative 2x. Well, 9 minus 2 is how much? That is 7. Okay, 9 minus 2 is 7. And 6x minus 2x is 4x, right? This is 4x. From here, in order to have the x on its own, let's divide both sides by 4. Divide by 4. Well, 4 cancels 4. And then the final answer for x will be equal to 7 all over 4. Well, let's check the options. Oh, there is no 7 over 4. Then, okay, this is normal, okay, because I write these questions down. So maybe when I was writing the options, I miswrite it, okay, or something like that. So maybe you can change any of the options, okay, to say let that option be maybe 7. Let's say maybe this is 7 over 4, okay. Then this will be the answer. Again, the most important thing here is the steps, okay? Is the steps. For example, let's verify our answer, okay? Because that's the best thing to do. Let's say 9 raised to the power of x. So instead of x, we put our answer, that is 7 over 4, okay? Then minus 1. Let's see what this gives us. This gives us a value of 5.196, okay? Just to 3 decimal places, okay? We just want to make sure that our answer is correct. Let's test this also. Let's say 27 raised to the power of 2x. So instead of x, we say 2 multiplied by, our answer is 7 over 4 minus 3. Well, this is also the same, 1.196. So as you can see, the left hand side and the right hand side are equal. So this is the correct answer, okay? So these options are wrong, but that is not a problem. I mean, the most important thing is that you understand how to solve, the solution, the concept. That's the most important thing. Let's move to question number 3. Question number 3 is about simplification of indices, okay? Then we have 3 raised to the power of 5. then bracket open and close, okay, raised to the power of 2. Then we have multiplied by 3 raised to the power of negative 4 divided by 3 squared. Also, bracket close, we have to the power of 3. Well, here again, we just use our rules, indices. This is what I want you to understand, okay, before I begin. If you have a raised to the power of b divided by a raised to the power of c, the bases are the same, right? A and a. So if they are being divided together, this is equal to, just take one of the bases, write a, the base, because the bases are the same, a. Then the power here in the numerator is b minus the power of the denominator, which is c. Okay? So in indices, if the bases are the same, if we multiply them together, we just add the powers, okay? Remember, I told you that when you have a raised to the power of c multiplied by a raised to the power of b, because we are multiplying them together, this is the same as just adding the exponents, c plus b. So if you are dividing them, it's like you just subtract the powers. And if you know this, this question is also easy. You can go ahead and solve. Well, we have 3 here raised to the power of 5, then we have 2 outside the bracket. And if you remember, bracket serves as multiplication, right? So just assume that you have a multiplication here or something like that. So you can just go ahead and multiply this. If you also want, there are different ways to solve this type of questions, okay? So it's up to you. But for the sake of this video, I'm just going to use the easiest method and then solve this. Let's say this is equal to, let's write it here. From here, 5 times 2 is 10. So we have 3 raised to the power of 10. Then multiply by 3 raised to the power of negative 4. We divide this by, here again the same. 2 multiplied by 3 is 6. So we have 3 raised to the power of 6. I'm going to continue the solution here, guys. I'm going to continue the solution here. Remember, I think I have to write it here. I say a raised to the power of b multiplied by a raised to the power of c is the same as a raised to the power of b plus c. Okay. So we are multiplying these two terms together. Well, the bases are the same, 3, so we just go ahead and then add the powers. So we have 3 raised to the power of 10 plus negative 4, sorry, negative 4. Then we divide it by 3 raised to the power of 6, and this is equal to, remember, positive sign multiplied by a negative sign is a negative sign. So this is the same as 3 raised to the power of 10 minus 4. Divide this by 3 raised to the power of 6, okay? And this is equal to 3 raised to the power of 10 minus 4 is 6, okay? We divide this by 3 raised to the power of 6. Well, as I said, from here, if the bases are the same, if you are dividing them, you just have to take the difference of the powers. That is, you subtract the powers. Let's go ahead and do that. Maintain 3, that is, the bases are the same. The power of the numerator is 6 minus the power of the numerator, the power of the numerator is 6 minus the power of the denominator is also 6. So this results to 3 raised to the power of 6 minus 6 is 0. Okay? And then, yeah, this is the same as 1 because anything raised to the power of 0 is just 1. Okay? This is the same as 1. But as you can see, we don't have any 1 in the options. So they want you to leave it in indices form. That is in this form. Okay? 3 raised to the power of 0. Then this is the answer to this question. And therefore, our answer is B. Okay? Let's move to question number 4. Question number 4. Again, we have an exponential equation. If 6 raised to the power of x plus 1 is equal to 8 raised to the power of 2x, what is the value of x? Now, this is what I want you to do. Pause the video, try to solve this question by yourself. then on pause and then continue watching and see if you get the answer correct. Okay, just verify your answer. I hope you are done. Let's continue. Again, we have an exponential equation, so we have to make sure that the bases are the same so that we can equate the powers. Let's go ahead and do that. So 16 is the same as 2. Maybe let me put it like this. Okay, 16 is the same as 2 raised to the power of 4. Again, as I said, we have two terms here. Because of that, we open a bracket, x plus 1. This is equal to, and 8 is the same as 2 raised to the power of 3. Again, if you don't know this, like what is 16, what is 8, try to punch it in your calculators, do trial and error, you will find out. But I think you all know about this. So 8 is the same as 2 raised to the power of 3. Then open a bracket, you have 2x there. Okay. Again, our bases are the same. Then we can go ahead and then equate these powers. Let's do that. So this is 4 into x plus 1. This is equal to 3 into 2x. And if you distribute this inside here, we get 4 multiplied by x is 4x. 4 multiplied by 1 is just 4, is equal to 3 multiplied by 2x, that is 6x. Now let's move 4x to the right hand side. Okay, well, this will give us 4 because only 4 remains here, and then the positive 4x will change to negative 4x. Okay, at the right hand side, so we have 6x there minus 4x. Again, 4 is equal to 6x minus 4x is 2x. In order to have x on its own, we divide both sides by 2, and then 2 will cancel 2. 2 goes into itself is just 1 times. 2 goes into 4 is 2 times. Okay, therefore x here is 2, and this is the answer to our question, that is option B. Okay, again, you can go ahead and then verify these answers if you want. Let's continue to question number 5. Again, we have an evaluation. It says evaluate 81 over 16 raised to the power of 3 over 4. Well, I mean, this type of questions, you can just go ahead and solve them with your calculator. Okay, you can just punch 81 over 16 in bracket. Okay, then you raise it to the power of 3 over 4, and then it will give you the answer directly. Okay, you can do that, but for the sake of this video, we are just trying to practice and then understand our rules, the properties of exponentials, indices, and so on. So I'm just going to go ahead and solve it. Yeah, let's do that. Again, we have 81. Well, what is 81? Well, 81 is the same as 3 raised to the power of 4. Let me check that on the calculator. Yes. So 81 is the same as 3 raised to the power of 4. Okay. We divide this by 16 is the same as 2 raised to the power of 4. We just said that earlier. 16 is the same as 2 raised to the power of 4. Then we have 3 over 4 outside the bracket. And this is equal to. Now, in indices, when you have maybe A raised to the power of B over maybe you have C raised to the power of B. Now, see here, notice this. A, C, they are different, right? The bases are different, but the exponents are the same, the powers are the same. You can go ahead and say this is equal to, you can factorize the power out. That is A divided by C in bracket all raised to the power of B. So this is the same as, this is the same as this, okay? So this exponent here, B, is both for A and C, okay? So these are the same. So if you know this, you can just apply it to this question here. So we can have 3 over 2 again. Let's take the 4 outside. 4 already there is 3 over 4. So that's the multiplication. Well, from here we can cancel 4 and 4. And then we have 3 over 2 raised to the power of 3. Okay? Again, as I said, this is the same as this. So you can go forward or backward. Okay? So in this case, we have to go backward. Okay? So we have to understand that means 3 raised to the power of 3 and then 2 raised to the power of 3. They share it. Okay? They share the power. Then we have 3 raised to the power of 3 over 2 raised to the power of 3. Then for the sake of this question, we have to go and evaluate it. What is 3 raised to the power of 3? If you don't know, just punch it in the calculator. 3 times 3 times 3, that is 27. 3 raised to the power of 3 is 27. Okay? Over 3 raised to, this is 2. 2 raised to the power of 3, that is 8. So therefore, this is just 27 over 8. That is option A. Again, if you want, you can just punch this in your calculator directly without doing any of these operations. Let's go ahead and continue with that's question number 6. Okay, the question says if 5 raised to the power of 2x plus 5 raised to the power of 2x plus 1 is equal to 750. Okay, this one is a bit tougher than the ones we have seen so far. What is the value of x? Okay, well, let's go ahead and then do this. Again, in the exam, if this is a multiple choice question, you can just do the trial and error with your calculator and see. It do takes time sometimes. At times it wastes time sometimes. It's up to you. But for the sake of this video, I'm just going to show you how to solve this question traditionally. Let's begin. Well, in this question, remember in the previous ones we normally try to change the basis, to make sure that we convert the basis of the numbers that we have so that the bases are the same, and then we equate the powers. Well, in this case, is it possible to put this basis the same? No. Well, what are we going to do? I'm going to show you that very soon. And by the way, this question is harder than any of the previous ones. Let me show you how to solve this. Well, I think you all know that if you have like maybe a raised to the power of maybe bx, well, in exponentials you can say a raised to the power of b in bracket x outside, and this is the same as a raised to the power of x in bracket b outside. It doesn't matter, because at the end of the day it is multiplication that is between them, because multiplication is commutative. Because multiplication is commutative, the order doesn't matter. It's just like when you say 2 times 3, this is just 6, and if you say 3 times 2 is 6, so the order does not matter. Okay, now what I'm going to do here is that I'm going to take this out. Okay, 2 out. This is what I mean. I'm going to say 5 raised to the power of x, okay, in bracket, then raised to the power of 2. If you are with me, what I explained here, this is the same as this, right? Again, let's continue. Plus, we are going to do the same for this one. Remember, I said this is the same as 5 raised to the power of 2x multiplied by 5 raised to the power of 1. If there is multiplication here, so mean that the bases are the same, okay, and then we multiply the power 2x and then 1. I explained this before. This multiplied by this is the same as this, because the bases are the same. You just add the powers. Okay, Now the first thing to do is to convert it into this form. Then from there, you go further and then rewrite this into 5 raised to the power of x, then 2 outside, as I did with this one, okay? Because as you can see, these two are the same. And 5 raised to the power of 1 is just 5 multiplied by 5. Then let's write this down. We have 5 raised to the power of x in bracket square multiplied by 5. Okay, this is what I just wrote here. And this is equal to 750. Well, from here, what do we do? Well, the easiest way to approach this type of questions, believe me, is to use substitution, okay? I'm going to say let maybe t, let's say t, let t be equal to 5 raised to the power of x. Do not panic, this is normal, okay? We are just letting t to be equal to 5 raised to the power of x. So meaning wherever we see 5 raised to the power of x, we replace it by t. For now, we are just letting it to be equal to this. There's no problem with that, you can do it, okay? Let's continue. So instead of 5x, we have t, and then we have square here. So this is just t squared plus the same thing here. We replace that by t. We have t squared, but multiply by 5 here, right? And this is equal to 750. Again, let's rewrite this. This is t squared plus, again, t squared times by 5 is just the same as 5t squared is equal to 750. Well, t squared, they are like terms, so we can add them. T squared plus 5t squared is 6t squared, and this is equal to 750. Okay, so we want to have t on its own. Let's divide both sides by 6. 6 cancels 6. We have t squared on the left hand side. This is equal to 750 divided by 6. I'm going to use a calculator for this. 750 divided by 6, that is 125. 125. Okay, well, we want to find t. Now, how do we find t from here? Well, to find t here, we take the square root of both sides. The square root of both sides. And this gives us here t, because this and this goes out. So t is equal to, don't forget, because we have a square root, the answer is either a plus or negative. So this is plus or minus. The square root of 125 is what? Is 5 root 5, okay? If you don't know that, you can just use your calculator. Just type it there. You know, the square root of 125 will give you plus or minus 5 square root 5. Okay? Or, I mean, by the way, we don't need to find the value of t, okay? Sorry, this was redundant, okay? There's no need for this, okay? Because in the question we are asked to find x, not t. So let's just leave it in the form of t squared is equal to 125. Remember this divide here is 125. So we have our t squared as 125. Okay, this is not the answer, by the way. I'm just going to maybe put some circle here. So t squared is 125. Well, remember here, what was the value of t? The value of t is 5 raised to the power of x, isn't it? So from here, instead of t squared, we are going to substitute 5x. Remember, t is the same as 5x. T is equal to 5 raised to the power of x, okay? Let's go ahead and do that. So instead of t, we are going to have 5 raised to the power of x. That is here in the t. So we have square there. We cannot forget the square. We open bracket and put the square. This is equal to 125. Okay. Let's just find the value of x directly, because there's no need for us to find t. There was no t in the question. We were the one who let t be equal to 5 raised to the power of x. So doing that will just waste our time. So this is the quickest way, okay? Because you know t is 5 raised to the power of x, just substitute it and then continue. Then from here, we are going to have 5 raised to the power of 2x, that is x multiplied by 2 is 2x, and this is equal to, well, for those of you who don't know, 125 is the same as 5 raised to the power of 3, okay? So this is the same as 5 raised to the power of 3. Well, again, the very first thing I explained, the bases are the same, so we can equate the powers, okay? Therefore, we can say 2x is equal to 3. Pardon me. Oh, okay, this was supposed to be x. Then to leave x on its own, we have to divide both sides by 2. 2 cancels 2. And then this gives us here x is equal to 3 over 2. Okay? 3 over 2. And 3 over 2 is the same as 1.5. Let's see what we have in the options. Wow, again, we don't have anything like that in the options. So again, I made a mistake in these options when I was copying the questions. As I said, we can cancel one of the options again. Maybe let it be, okay, let's say this one maybe. Just make this a 3 over 2. And then say our answer is C. Okay. Again, if you want, you can go ahead and then verify. If you punch in your calculator, here, if you replace the value of x with our answer, which is 3 over 2, you are going to get 750. So that is the correct answer. Okay? The answer to this question is 3 over 2 or 1.5. Let's continue. We have question number 7. This one also is a simplification question. Again, the same approach. We have base 2, 8, base 8, we have base 4. We want the bases to be the same, okay? And most of the time, if you have this type of questions, look at them. Which one is the smallest base here? Is it 4, 8, or 2? Obviously, it's 2. 2 is the smallest base. So just try to convert all of them to the base of 2. That will make your work easier. So let's continue on. Let's go ahead and do this. We have 2 raised to the power of 3x. We won't touch that. Remember, we said 8 is the same as 2 raised to the power of 3. So 2 raised to the power of 3, we have x minus 1 there. So we open a bracket and write that inside. 4 is the same as 2 raised to the power of 2. Again, we open a bracket. We have the exponent 2x here. We put that there. From here, I'm just going to go ahead and write this down here, okay? From here, let's expand. We have 2 raised to the power of 3x multiplied by, let's distribute this inside, okay? Inside, that is 3 times x is 3x, 3 times negative 1 is negative 3. We divide this by, here also the same, we just multiply. 2 times 2x is just 4x. Okay. Again, the bases are the same. If the bases are the same and we are multiplying them, okay, if the property between them is multiplication, what do? We add the powers together. So this is the same as 2, because the bases are 2, 2. We maintain 1, 2, and then we add these powers together. That is 3x plus 3x minus 3. Then we divide this by 2 raised to the power of 4x. This is the same as 3x plus 3x is 6x. So we have 2 raised to the power of 6x minus 3 divided by 2 raised to the power of 4x. Okay. Let's continue here again. I explained this property when you have 2 bases that are the same, and then if they are being divided together, what you can do is just to maintain the base, that is 2, and then subtract the powers. Okay, we have 2. You begin with the numerator. You start with the numerator. The power of the numerator is 6x minus 3. Then we subtract from that minus. The power of the base is 4x. Okay, so this is the same as this, and this is equal to, well, we have 6x negative 4x. These are like terms. Okay, they both have x in them, so let's go ahead and do that. That is 6x minus 4x is 2x. So we have 2 raised to the power of 2x, and then because this negative 3 is an unlike term, okay, it has no x, so we cannot add that. And this is the final simplification. Let's look at the options, then we can adjust accordingly. Well, in the options we have no x in the options, right? So again, meaning I made a mistake again in writing the options. This is the answer. Okay, yes, this is the final answer. 2 raised to the power of 2x minus 3. So instead of that, I wrote 2 raised to the power negative 3 only. Yeah, maybe I have to, again, as I said, maybe let's change this option here. Okay, so let's say this is 2 raised to the power of 2x minus 3. Then our option, the answer is D. Okay, don't mind about the options. The options are not very important. If you understand the concept, the explanations, that is all. Okay, let's move to question number 8. Well, question number 8 is not a very difficult one. They said if 4 raised to the power of x plus 4 raised to the power of x plus 4 raised to the power of x is equal to 192, what is the value of x? Now, this is what I want you to understand. Do you know why if you have x plus x plus x, the answer is 3x? Do you know? That is because each of these x's have a coefficient of 1. The coefficient is 1. The coefficient is 1. So 1 plus 1 plus 1 is 3. And the terms are x, so you just maintain 1x. Isn't it? We are going to use the same concept here, okay? This, and this, they are the same. So if we assume that we have a coefficient of 1 in front of each, a coefficient of 1 multiplied by these terms, okay? Then 1 plus 1 is 3, okay? So we can go ahead and say this is the same as 3 multiplied by, the terms are 4 raised to the power of x, this, just as here, okay? It's 3, then you bring that one of the terms, you have x, you just multiply, you just maintain 1x. Here also you just maintain 4 raised to the power of x, okay? So it's the same. Or if you want another way also, you can do it without of course, if you don't understand that the coefficients are just 1, without doing that method also, you can just go ahead and do this, okay? Let me show you that. You can factorize, okay? You can say, okay, 4 raised to the power of x or 4 exponent x is common. You take it out. Well, if you divide this by 4 raised to the power of x, the answer is 1. The same thing applies to this one again, 4 raised to the power of x. If you divide, the answer is 1 plus 1. Here also, if you take 4 raised to the power of x, the answer is just 1, okay? Plus 1. This is another method you can use. Again, it doesn't matter whether you use the previous one that I show you or this one, they are both the same because we are going to end up with 4 raised to the power of x. 1 plus 1 plus 1 is just 3. This is equal to 192. Again, as I said, it's the same thing. So you have 3 multiplied by 4 raised to the power of x. Again, multiplication is commutative. It doesn't matter if you multiply 4 raised to the power of x with 3 or 3 multiplied by 4 raised to the power of x is the same. This is equal to 192. So as you can see, both methods gives us the same thing, okay? The same expression here. Well, we want to have 4 raised to the power of x on its own. So let's divide both sides by 3. 3 will cancel 3. And then 192 divided by 3, I'm going to use a calculator for that, just to make our work easier and faster. So this is equal to 4 raised to the power of x is equal to 192 divided by 3 is just 64, okay? And then for those of you who know, 4 raised to the power of x is equal to 64. This is the same as 2 raised to the power of 6, okay? You can check that in your calculator and see. It's the same as 2 raised to the power of 6. Well, but because here we have 4, again we can go ahead and change this 4 into an how will I call it? Into a base of 2, okay? That is 2 raised to the power of 2x, and then solve the question. Or if you want, instead of 2, again we can use 4, okay? Because this is also the same as 4, again raised to the power of 3. So 2 raised to the power of 6 is 64. 4 raised to the power of 3 is also 64. So it doesn't matter whether you go by this or by this, I mean, you'll get the same answer. So I'm just going to go and use 4 because we have this base here as 4. So it will be better we make this also in a base of 4. We convert to base 4. So that is going to be, our base number is here is going to be 4 raised to the power of 3. Again, according to the property, these bases are equal, then we can equate the powers. That is, x is equal to 3. And this is the final answer to this question. That is option B. Let's continue. Again, if you want, you can go ahead and then verify the answers, as I said. Also, if there is any point that is not clear or any question that you don't understand, please feel free to leave it in the comment sections. Ask your questions there. I will get back to you. I'll try to answer them as soon as possible. Okay, let's continue with this question. Again, there is nothing new. We have base 2, base 8. We just try to convert 8 to a base of 2. That's the first step to do. Again, let's write this 2 raised to the power of x plus 3 divided by, well, 8 is the same as 2 raised to the power of 3. Again, we have these terms there, so we have to put them in a bracket. This is equal to 4. Let's continue here. We have 2 raised to the power of x plus 3 divided by, let's distribute 3 inside. That is 2 raised to the power of 3 times x is 3x. 3 times negative 1 is negative 3. This is equal to 4. Again, well, if you remember, I showed a property that if the bases are the same, and then if you have division in between them, you can just subtract the powers, okay? So let's go ahead and do that. We have 2 raised to the power of x plus 3 minus, we are going to subtract the power of denominator. But here the power of the denominator is not one term, it's 2 terms, okay? So that's why it is very important that we open a bracket and write 3x minus 3. Sorry, let me take that back. 3x minus 3, okay. And this is the how will I call it? This is the mistake most of the students make. They will go ahead and say, okay, 2 raised to the power of x plus 3 minus, then they will just say minus 3x here and then minus 3, okay? And this is wrong because you only distribute a minus sign to this, not to this, okay? So both of them should have the minus. That is, the minus should affect both 3x and then 3. So that's why if you put the minus and I put a bracket, it will be easier for you so that you can distribute the negative sign inside, okay? Be careful of that. It's a mistake many students make. So this whole thing is just equal to 4, okay? because we have an equation, okay? Our right hand side is 4. And but this is the same as 2 raised to the power of x plus 3. Now we are distributing the negative inside the bracket. That is negative multiplied by, by 3x, that is negative 3x. Negative multiplied by negative 3 is positive 3. This is equal to 4. Let's go ahead and do this. Well, let's add the like terms together. X, negative 3x, this is negative 2x, okay? Then we have 3 plus 3 is 6. This is equal to 4. Well, the bases are not the same. Can we make the bases the same? Of course. 4 is the same as 2 raised to the power of 2. So let's do that. Let's continue here. We have 2 raised to the power of negative 2x plus 6. This is equal to 2 raised to the power of 2. Well, now the bases are the same, 2, 2. So we can go ahead and then equate the powers. That is negative 2x plus 6 is equal to 2. Okay, let's continue here. Now, it is up to you. You can just move this here and then you divide all, but I just want to move negative 2x to the right hand side so that the sign can change to positive, So this is just going to be, we are going to move this here and then move this here. So we have 6. If we take positive 2 to the left hand side, it changes to negative 2. And then negative 2x to the right hand side changes to positive 2x. Let's continue here. 6 minus 2 is just 4. This is equal to 2x. In order to have x on its own, we divide both sides by 2. 2 cancels 2. 2 goes into itself 1 times. 2 goes into 4 is just 2 times. Therefore, the value of x for this question is 2. Let's see our options. Yes, we have that here. Option C. Again, you can verify your answers if you want. And this is our last question for this video. Well, if 27 raised to the power of x minus 1, okay, or closing bracket, or parenthesis if you want, raised to the power of 2 is equal to 9 raised to the power of 3x. What is the value of x? Again, there is no new thing, okay? The bases are different. Let's make sure that we make the bases the same. That's all we have to do, and then equate the powers. There's nothing new, okay? Let's go ahead and do this. Remember, we did it before. 27 is the same as 3 raised to the power of 3. So instead of 27, I'm going to write 3 raised to the power of 3. And then we have a term there, so I have to open a bracket and put x minus 1. That is this term here. Well, we have another big bracket, okay? So I'm just going to, parenthesis, but I'm going to just use a big bracket like this, just to differentiate it from this, just not to mix it with this, okay? If you want, you can just go ahead and open your bracket, your parenthesis, there's no problem. Then we have a power here, 2. I'm going to write that 2 here. This is equal to, well, 9 is the same as 3 raised to the power of 2. Again, we have exponent 3x there, we multiply them. This is equal to, let's go ahead and distribute this inside the bracket. We have 3 raised to the power of 3 times x is 3x. 3 times negative 1 is negative 3, okay? Again, we bring our parenthesis or bracket if you want, and then the 2, power 2. This is equal to, let's multiply this together. We have 3 raised to the power of 2 times 3x is 6x. Okay, sorry, let me rewrite it. Is 6x. Then from there, remember, we have a parenthesis between them or a bracket, so it's just as multiplication. So we just have to multiply this term with this term. Okay, so let's distribute the 2 inside. But this is going to be, no, this is the same as, let me even write it in this form so that you wouldn't be confused. Let me write it in this form. Sorry. you can just write this in this form, put small bracket here and multiply 2 here. It's the same thing, okay? It's the same thing. I just want to show you that we are just distributing this inside. So this is 3 raised to the power of, well, 2 multiplied by 3x is 6x, okay? And then 2 multiplied by negative 3x is negative, sorry, it's not negative 3x but negative 3. 2 multiplied by negative 3 is negative 6. This is equal to 3 raised to the power of 6x. Again, the bases are the same, 3, 3. We go ahead and then equate the powers. That is, this exponent here equal to this. So we have 6x minus 6 is equal to this. And I hope, how will I call it? It is not confusing to you because I'm saying exponent, power, indices, they're all the same, okay? They're the same, all right? You don't have to be confused about that. Well, let's continue. Oh, wait a moment. There is a mistake. We made a mistake because this is not possible. Well, that is going to be, if you move this here, it's just going to be 0 is equal to negative 6. Oh, sorry, 0 is equal to 6, which is not true. There's a mistake. Where's the mistake? Okay. I get it. I get a mistake, I think. Yeah. No, wait. Where's the mistake? This is 9 is the same as 3 raised to the power of 2. Well, there's no mistake. Well, the question has a problem. Okay, guys, there is no mistake in our, in our solution, okay? In our operation, there is no mistake. The mistake is in the question, okay? So this has no solution. But wait a moment, I can change something there. Let's just make sure that we have a solution, okay? So let me change something like maybe instead of 9 raised to the power of 3x, let's say 9 raised to the power of negative 3x. Let me put a negative here. Oh, that is not showing. Let me put it in red. Negative 3x, okay? We assume that there is negative there. Then let's replace the negative here. Again, let's replace the negative here. Yeah, for the sake of solvability, okay? Because the question was wrong, you know, there was something missing in the question. That's why we end up with no solution, something like that. So we have to make sure that we change something. And again here, yes, so we just replace a minus sign inside the question, so that affects everything. Then from here, if we are to continue to solve this question, again, it's very simple. Just move this here, move this here. That is going to be 6x. Negative 6x when brought to the left hand side changes to positive 6x. This is equal to negative 6x when taken to the right hand side changes to positive 6, okay? And this is equal to 6x plus 6x is 12x. This is equal to 6. In order to have x on its own, we divide both sides by 12. 12 cancels 12. Again, okay. 12, okay, we can divide it by 6. 6 goes into 12 is 2 times. 6 goes into itself is 1 times. So that is 1 over 2. Therefore, the value of x in this question is 1 over 2. This is the answer. Of course, that is when we do, after changing this expression, after plugging the negative sign there, we correct the question because the question was wrong, and then the answer is 1 over 2. As I said again, the concept is what is important, because in your exams there wouldn't be a mistake. I promise you that everything will be correct, okay? Just take your time and then solve the questions, you will get the correct answers. And for here, maybe we can just change this to 1 over 2 instead of 1 and choose that as our answer, because our answer is 1 over 2. Yes, this is all for this video. And please, if you like this video, consider subscribing to my channel, like, comment and share. And please tell me in the comment sections what videos would you like to see, like on which topics do you want me to make videos, on which SAT topics. And thank you for watching this video.